So last class we discussed about operations on discrete time signals, right? So how to do shifting, scaling and time reversal. So I had given you a problem x of n which is equal to 8 minus n into u of n minus u of n minus 8. Okay. So how do you go about to solve this problem is first you have to plot this. Okay, what is u of n minus u of n minus 8? You people know u of n is a unit step signal, correct? It will start from 1 and it will go up to infinity with an amplitude of 1. Okay, it will start from 1, it will go up to where n is equal to infinity with an amplitude of 1. Okay, it is 0 for negative values of n. This is unit step signal. So we have u of n minus u of n minus 8. So we shall see how to plot u of n minus 8. So u of n minus 8 is shifting operation of unit step. Okay. So here you have u of n minus 8. The k is negative, that means right shift. Okay. So your signal will be delayed by 8 seconds. So your signal is starting from 8 and it will go up to infinity. Okay. This is u of n minus 8. So now we have to plot u of n minus u of n minus 8, correct? So you have to subtract this from this. So how do we do that? So you can directly do or you can check the amplitudes. So see the amplitude at 0. You have 1 here and you have 0 here. So 1 minus 0 is 1. Similarly, it will go on up to 7. Okay, because here you have all ones, here you have all zeros up till 7. So it will be 1. At 8, what happens? Here at 8 you have 1. Here also at 8 you have 1. So 1 minus 1 it will be 0. Okay. At instant 8 the signal will be at 0. So this is your first part. Okay. So second part is you have to multiply. You have a multiplying factor 8 minus n with the u of n minus u of n minus 8. So with this signal u of n minus u of n minus 8, multiply this 8 minus n. What does 8 minus n mean? It means that at n is equal to 0, you have 8 into 1, that is 8. Okay, at instant 1, at n is equal to 1, you have 8 minus 1 into 1, which is nothing but 7. So here you have amplitudes 1 here, u of n minus u of n minus 8. So 1 into this amplifying factor. Okay. So similarly, you will get 8, 7, 6, 5, 4, 3, 2, 1 up to 7. Okay, at 8 it is 0. So don't worry about that. Till 7 you will get 1. So this is our x of n. So you are being told to plot x of 4 minus n and x of 2n minus 3. Okay. So how do we plot this x of 4 minus n? So you have x of n plus 4. First you have to do shifting, then time reversal. Okay. So plot x of n plus 4, then plot x, then take time reversal of that to get x of 4 minus n. Okay. The time reversing n you have plus 4 minus n. Okay. So do first n plus 4, then time reverse that to get x of 4 minus n. So what will you do if you have x of minus 4 minus n or x of minus n minus 4? First, what will you plot?
n minus 4.
You will plot x of n minus 4, then time reverse that to get x of minus n minus 4. Got it? So this is how you go about to solve this. Okay, so first we have 4 minus n, okay, plus 4 minus n. So first we will plot x of n plus 4 in this problem. So x of n plus 4 means k is positive. So it is left shifting. Okay, so the signal will occur 4 seconds earlier. Okay, here it was occurring 4 seconds late, right? U of n minus 8 means k is negative, right shifting, and that signal occurs 8 seconds late. But if you have positive sign, it is left shifting and that signal will occur that many instants earlier. Okay. So you have a signal starting from 0 up to 7. So if k is positive, left shifting by 4 instance. Okay, that signal will occur 4 seconds earlier. So we have a signal from minus, whatever is at 0 will go to -4, whatever is at 1 will go to -3, so on. Okay. So we had seen this. What is x of n plus 4? And x of 4 minus n is time reversal of that. Okay, this you time reverse. Whatever is at -4 will go to +4, whatever is at 3 will go to -3. Just time reverse it. Mirror image. Fold this signal with respect to vertical axis or y-axis. Okay, you'll get x of 4 minus n. Later I told you to do this by yourself because it was time up. It was x of 2n minus 3. Correct? So how did you all do this? You have any doubts? X of 2n minus 3? You have any doubts for x of 2n minus 3? I'll plot this here. First, we have to do x of n minus 3. K is negative, so right shifting. Okay, so first I'll plot my signal x of n, which is nothing but at 0 it is 8, at 1 it is 7, at 2 it is 6, at 3 it is 5, at 4 it is 4, at 5 it is 3, at 6 it is 2, at 7 it is 1. Okay, so you draw it properly. I have just drawn roughly. So we have x of n minus 3. First we have x of 2n minus 3, right? So according to the precedence rule, we have to do shifting first. So we are doing x of n minus 3, then we'll scale it to x of 2n minus 3. Okay, now I'll plot x
Of n is from 6, ma'am. Amplitude 6.
what?
X of n is wrong, ma'am. You are written.
8, 7, 6, 5, 4, 3, 2, 1. Why?
Ma'am, you are given different, ma'am. U of n minus a, U of n minus 6.
U of 1 minute. This is x of n, right? This is what I have plotted there.
Next problem.
Ma'am, that is the
I'm
next
telling
problem.
you,
What
Ma'am,
is
that is
it?
for next problem, ma'am.
I'm doing previous one.
Ma'am, you are doing homework problem, no, ma'am.
Yes, no, yeah, I had told you to
In
do
that
this
you are given 6
previous.
minus n of U of n minus U of n minus 6.
I'm doing 8 minus only, 8 minus n, previous one. This part I left it right, x of 2n minus 3. Did you people do that? In this problem only I had told you to do x of 2n minus 3 also, right? In 8 minus n. Did you do that? I'm doing the last class problem only still. Okay?
Yes, ma'am. Yes.
So this is our x of n. So we have x of n minus 3. Okay? X of n minus 3 means the k is negative. So it is right shifting. The signal is occurring 3 seconds late. So whatever is at 0 will occur at 3. Okay? 3, 4, 5, 6, 7, 8, 9, 10, 11. I'll just put randomly n values. So whatever is at 3, 0 will go to 8. Will go to 3. Okay, that is amplitude 8. So this is 8, 7, 6, 5, 4, 3, 2, and 1. Got it? So this is our x of n minus 3. So now we have to do scaling. Shifting is done. We have shifted 3 instances to the right. Now we have to scale it. X of 2n minus 3. Okay. So we are scaling by a factor 2. So we shall see how it will look. X of 2n minus 3. Okay. I'm doing the previous problem only. 8 minus n into u of n minus u of n minus 8. Okay. This is my x of n. So x of 2n minus 3 means I'm scaling by a factor 2. So what happens here? I'll scale it by 2 everywhere. So what happens? 3 by 2, what it is? It's 1.5. In discrete time signal, Only integer values are allowed. 1.5, 2.5 and all is not allowed. Correct? So this signal is lost. This signal is lost. This is also lost. This is also lost. Okay, whatever is at 4 will come to 2, which is nothing but with amplitude 7. Okay, then whatever is at 6 will go to 3, that is with amplitude 5. Whatever is at 8 will go to 4, that is amplitude 3. And whatever is at 10 will go to 5, which is amplitude 1. Understood everyone? Scaling. Got it?
Yes, ma'am.
You have any? So I have also given you one more problem. 6 minus n. Correct? 6 minus n into u of n minus u of n minus 6. So I told you to plot x of 4 minus n and x of 2n minus 3. Okay. So do it in a similar way. So you have u of n. It's a discrete time unit step. So its amplitude is 1 from 0 up to infinity. It will go on. Okay, 1, 2, 3, 4, 5, 6, 7. Up to infinity, it's 1. Then you have u of n minus 6. U of n minus 6 means the signal will start from
0
ma'am.
to 5.
no.
Ma'am, 6 to
See, your
13.
signal is starting
Yes, ma'am.
from 0. Correct.
It
You're
starts from
shifting.
6, ma'am.
K is negative. Okay, you have right shifting. The signal will start from 6. And with an amplitude 1, it will go on up to infinity. Okay. So now you subtract u of n minus u of n minus 6. So from where to where will a signal exist? If you subtract these two signals, if you subtract this and this,
0 to 5, ma'am.
yeah. So 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5. Got it? So this is u of n minus u of n minus 6. Correct? Now we have an amplitude factor, that is 6 minus n. So that is our x of n. So you have 6 minus n into u of n minus u of n minus 6. So 6 at n is equal to 0, it will be 6 minus 0 into 1. It will be 6, amplitude will be 6 at 0. At 1, it will be 6 minus 1 into u of n minus 6, it will be 5. At 2, it will be 4. At 3, it will be 3. At 4, it will be 2. At 5, it will be 1. Got it? This is your x of n in the homework problem. Got it, everyone?
Yes, ma'am.
Now I have told you to plot. What did I tell you to plot? X of 4 minus n and x of 2n minus 3. So for plotting x of 4 minus n, you have to plot x of n plus 4 first. Okay? X of n plus 4. So n plus 4 means from where will the signal start? This is your x of n.
Minus 4, ma'am.
The signal will start from minus 4 because here k is positive, it is left shifting and the signal is occurring 4 seconds earlier. Okay, what is at 0 will go to minus 4. So at minus 4 you have 6, at 3 you have 5, at minus 3 you have 5, at minus 2 you have 4, at minus 1 you have 3, at 0 you have 2, and at 1 you have 1. So this is x of n plus 4. Now I'll time reverse this. So I'll get x of
Ma'am, can you explain the 6 minus n into un minus u of n minus u of n minus 6, that part?
Yeah, you have u of n minus u of n minus 6. That means you have samples from 0 up to 5, correct?
Yes, ma'am.
So 6 minus n. So at n is equal to 0, put 0 here. 6 minus 0 into u of n minus u of n minus 6. In u of n minus u of n minus 6, amplitude is 1 only, right, for all samples. So you're just having an amplifying factor at the beginning, 6 minus n into 1. So at n is equal to 0, 6 minus 0 into 1. So 6 minus 0 into 1 is 6 only at n is equal to 0. At n is equal to 1, 6 minus 1 into 1. 6 minus 1 is 5.
Got it.
5 into
Only
1.
the amplitude is getting like amplified according to the factor.
Yeah, according to the value of n, you are getting that value. If n is equal to 2, you have 6 minus 2 into 1, 4. Correct? If n is equal to 5, 6 minus 1 into 1. Right? 6 minus 5 into 1. Right? I'm sorry, 6 minus 5 into 1, that will be 1. Got it? At n is equal to 3, you have 6 minus 3 into 1. That is 3. Follow?
Yes, ma'am. Got it.
Everyone understood? Still anyone has any doubt? Just substitute the value of n at each instant. Okay, you'll get the amplitudes decreasing. Okay, now we have plotted x of n plus 4, which is left shift of 4 instants, and the signal is occurring 4 seconds earlier. We have left shifted this signal, and we have to time reverse that to get 4 minus n. Okay, so I have minus 1 here, and 1, 2, 3, 4, 5, 6. This is my n axis. So at minus 1, I have 1. At 0, it will be 2 only. At 1, it will be 3. At 2, it will be 4. At 3, it will be 5. And at 6, it will be, sorry, at 4, it will be 6. Okay, so I'm taking mirror image of this time reversal. Okay, so if I fold this with respect to vertical axis, whatever is at 1 will go to minus 1, and whatever is at minus 4 will go to plus 4. Okay, just folding or mirror image. So this is my x of 4 minus n. Okay, quickly we'll do x of 2n minus 3. So to plot x of 2n minus 3, you have scaling operation, that is you have 2 and you have shifting. So according to precedence rule, first you have to shift it. So you have x of n minus 3 first. So if this is my x of n, and if I want to plot x of n minus 3, from where will my signal start?
Plus 3.
What about others? Will it start from plus 3?
Yes, ma'am.
Okay, so we have a signal at 0 and you have k negative. So it is right shifting. The signal is occurring 3 seconds late. Okay, so whatever is at 0 will go to 3 plus 3. So whatever is at 0 will go to plus 3. So at 0 I have amplitude 6, right? 6, 5, 4, 3, 2 and 1. And whatever is at 5 will go to 8. So this is my x of n minus 3. So now I have to plot x of 2n minus 3. That is, I have to scale it by a factor 2. So if I scale it by a factor 2, what happens? The signal will be compressed or expanded.
Compressed.
It will be compressed, right? Because the scaling factor is an integer. So the signal will get compressed. So we shall see. So whatever is at 3 will be lost, because 3 by 2 is 1.5. In discrete time, we don't have 1.5, 2.5, 3.5 and 4.5. Okay. So whatever is at 4 will come to 2, that is 5. And whatever is at 6 will come to 3, that is amplitude 3. And whatever is at 8 will come to 4, that is amplitude 1. Got it? Understood, everyone? See, at 3 by 2 is nothing but 1.5. In discrete time, we don't have these fraction values. We have only integers. Okay. So 3 by 2, the signal will be lost. At 3, the signal will be lost. Again at 5, if you scale it, you get 2.5. That signal also will be lost. And you have 7 by 2. It's nothing but 3.5. This also will be lost. The signal at odd values will be lost. Okay. 3, 5, and 7 will be lost. Whatever the signal you have at even values of n will be present. Okay. Clear, everyone? So I had also given you one more problem. Did you try that?
Yes, ma'am.
You want me to do that, or you have done? So I have given you a signal -1 to 0. It's a ramp. Then it is a step. This is 2, 1 and 2. Did you try this, everyone?
Yes, ma'am.
So what did I give you to plot? Given x of t, plot 4x into 2t plus 3, and I also gave you 2x into minus t by 2 minus 3. Did you plot this, everyone? You have any doubt in plotting, or you want me to plot and show?
We did.
Yes? You want me to plot and show, or you have done? Everyone has to reply. Why you are silent?
Yes, ma'am, we did.
What about
We
others?
did, ma'am. We did, ma'am.
Shall I draw the final waveform for you to verify?
Okay.
So for 4x, 4 into x of 2t plus 3. So minus t by 2 minus 3 you have here. Yeah. So we have 4 into x of 2t plus 3. So this would be from where to where? From where to where will the signal exist? First one. You have done right. Tell me from where to where will it exist? Time axis I'm asking you.
Ma'am, -2 to -0.5.
Correct. So minus 2, minus 1.5, minus 1 and minus 0.5. What about others you have done?
Yes, ma'am.
You are feeling difficult if I draw the final answer, or you are able to do it? So what is the amplitude here and what is the amplitude here?
Ma'am, 4 2. Sorry, ma'am.
4 and
8
2.
and
4 and
8, ma'am.
8, right? Got it, everyone? You got the same?
Ma'am, you have given
Others?
this one previously.
What?
You have given this problem, ma'am. We have done previously.
No, I have given homework, right? I have given this as homework. I have given this also as homework for you. Previous class. Okay. And you have 2x of minus t by 2 minus 3. I didn't solve this. I told you to solve it.
Yes.
So from where to where will this signal exist? You have to tell fast if you have done. So first what you will do here, you will do x of t minus 3. Then you will do x of t by 2 minus 3. You will scale it. So the signal will expand at this stage. Then you will time reverse that. X of minus t by 2 minus 3. Then you will amplitude scale it. Correct? Then you will do 2 times x of minus t by 2 minus 3. Yes or no?
Yes, ma'am.
Yes, ma'am.
So tell me from where to where will the signal exist?
Minus 10
Minus
to
10
minus 4.
to minus 4.
Correct. Minus 10, minus 8, minus 6, minus 4. So the signal will be like this. Correct? Is it correct what I'm drawing?
Yes, ma'am.
So what is amplitude here and what is amplitude here?
2 and 4.
Correct. It is 2 and 4. Got it, everyone? Understood? Or you want me to do this? Or you have done it?
We have done, ma'am.
Okay, fine. So we'll move on to next topic for today. So today we shall see a problem. Plot the waveform and its derivatives. You have to take the draw the derivatives also of the waveform. Okay, so they have given you two waveforms A and B. So first one is x of t, which is equal to u of t minus u of t minus a. This is the first waveform. You have to plot it.
New topic, ma'am.
No, we are continuing operations on signals and derivatives. Derivatives means differentiation function. These are problems on scaling operations only. Scaling, shifting, time reversal. Operations on signals. This is not new topic. It is operations on signals. So we have seen all three operations, right? Shifting, scaling, time reversal. So now we'll be using all these three and we'll be solving different types of problems. Okay? So this is the first one. X of t is equal to u of t minus u of t minus a. You have to plot this waveform and do the differentiation of this and its derivatives. Okay, how to plot the derivative of x of t. Okay, what is the differentiation of unit step? Had told you, right, when I was explaining elementary signals, differentiation of unit step is, just recall that, and you have been given y of t, which is equal to t into u of t minus u of t minus a. So you have to plot these two waveforms x of t and y of t, and you should also plot their derivatives. Okay, shall we start plotting this? What is the differentiation of unit step?
Impulse.
D by dt of u of t is nothing but delta t or impulse signal, correct? So if you integrate delta t with respect to dt, you get u of t. Then one more thing also I had told you. If you differentiate d by dt of ramp, signal would be, differentiation
U
of
of
ramp
t.
will be
U
u
of
of
t.
t. Similarly, if you integrate u of t with respect to dt, you get r of t. You keep this in mind, it will be handy for solving problems like this. So first we'll start with this, we'll plot these two, then we'll find the derivative of this and we'll plot the derivative also. So you'll be asked such type of problems also, okay, in your exams and all. So first we'll see what is u of t. We know what is u of t. It is a unit step signal. It will start from 0 and it will go up to infinity with an amplitude 1. Correct? Continuous time unit step. And what is u of t minus a? What is u of t minus a? A is some constant. It is like K only. Okay, so from where will the signal start for U of t minus A?
From
A,
plus
ma'am.
A.
We don't know what is A. Okay, so the signal will start from, so here K, so K is a constant, here we have A is a constant. So this A is negative, that means right shifting, and the signal is occurring A seconds late. Okay, so the signal is starting from A and it's going up to infinity with an amplitude of 1. Understood everyone? Got it? Assume if A is 4, the signal will start from 4. Correct? U of t minus 4 means the signal will start from 4. If it is 6, the signal will start from 6. We don't know what is that constant. They have just told it is A. So we'll assume it as A. A is some constant and we'll plot it with respect to that. Clear everyone? U of t minus A. So now we have to subtract these. So what do you get? U of t minus U of t minus A. How will that signal look? From where to where will it be existing?
0 to A, ma'am.
0 to A, correct? Because the signal U of t is 1 from 0 up to infinity. This U of t minus A is 1 from A up to infinity. So 1 minus 0 would be 1 up to A. Okay. So the signal will be 1 from 0 to A. Got it? This is my x of t. Correct? What is x of t? It is u of t minus a. Now we'll plot y of t. Then we'll plot the derivatives. Y of t is t into u of t minus a. So this is x of t. Now we'll plot y of t. So y of t is nothing but t into u of t minus a. So you are having amplifying factor as t. So how will the signal look? What will you do? At t is equal to 0, the signal will be at 0 only. Correct? 0 into 1 will be 0. At 1, it will be, at t is equal to 1, it will be 1 into 1. The signal will be 1. At 2, it will be 2 into 1. It will be 2. It goes on. At a, it will be a into 1. Got it everyone? With an amplitude 1. Followed?
Yes, ma'am.
Got it? I cannot tell amplitude as 1. So it depends. It depends on A. Correct?
Can you explain this once again, ma'am?
Yeah. So you have u of t minus a. So what is y of t? They are telling you to plot t into u of t minus a. You are having multiplying factor at t. So this signal u of t minus you have to multiply with t. Okay. How will you multiply with t? At t is equal to 0, 0 into this one is 0. At 1, 1 into this signal is 1. At 2, t is equal to 2. 2 into this is 2. At a into this signal is a with an amplitude a. Got it? Followed? This signal, see this signal we are multiplying with t. This signal is 1 from 0 up to a. U of t minus a is 1, right? So your y of t at t is equal to 0 is 0 into u of t minus a, amplitude is 1. At t is equal to 1, it is 1 into 1. So at 1, instant 1, it will be 1 here. Okay, at t is equal to 1. At t is equal to 2, the amplitude would be 2. It will be 2. 2, t is 2, right? We are substituting the value of t, like how we did for n previously, like that we are doing. At t is equal to 2, you have 2 into 1, which is amplitude is 2. At t is equal to 3, you have 3 into 1, which is 3. At 3. Like that only we don't know what is a. At t is equal to a, it will be a times 1, which is nothing but a. Correct? Yes or no? We
Yes,
are
ma'am.
multiplying with the factor t. This signal is multiplied with the factor t. So this is what happens. Clear?
Yes, ma'am.
Clear everyone?
Yes, ma'am.
You have any doubts still? Or it's clear? Can we move ahead? So we
Ma'am,
have
1
plotted,
second we are writing.
yeah, you can take down. You have to solve in your notebook side by side. Okay, if you want time, you please ask me. I'll give you time.
Ma'am, can you go a bit slow, ma'am, please?
Sure. You followed whatever we discussed now? Whoever asked me to go slow, did you follow this problem till here? It's clear?
Yes, ma'am, the last part.
Last part want me to
The y
explain?
of t, the y of t.
Yeah. So you have been given two signals x of t and y of t. They're telling you to plot the waveform and its derivative. First, we'll try to plot the waveforms x of t and y of t. What is x of t? It is u of t minus a. This is the given waveform, that is x of t. Y of t is t into u of t minus a. Correct? You are multiplying this signal with the factor t. So this is a unit step. Correct? What is the amplitude of this unit step? It is 1. So we are multiplying with the factor t.
Okay. So, ma'am, in this, the t, according to the value, the amplitude will change. That's it.
Yes. At t is equal to a, amplitude will be a. At t is equal to 2, amplitude will be 2. Just an example I gave 1, 2, 3. Because directly if I tell a, you'll be feeling difficult to understand. So at t is equal to 1, at 0, substitute the values for this. At 0, t 0, 0 into 1 would be 0. At t is equal to 1, 1 into this 1 will be 1. At t, if t is equal to 2, 2 times this will be 2. 3 into this will be 3. A times this signal will be A. Got it? Amplitude would be A.
Yes, ma'am.
Got it? Did you all take down this? Shall we move ahead? So they have told us to plot x of t and y of t. So we have plotted this. They also told us to plot the derivatives of this. Okay, now we have to take the differentiation of x of t and y of t. Done, everyone? Completed till here, everyone?
Yes, ma'am.
Shall we move ahead?
Yes, ma'am.
So now they told us to plot the differentiation, derivatives of x of t and y of t. So d by dt of x of t would be what? What is the differentiation of u of t?
Delta T, ma'am.
Delta t. What is the differentiation of u of t minus a? Shifting property. It will be delta of t minus a. Got it? Got it, everyone? We are just differentiating this function u of t minus a. Differentiation of u of t is delta t and differentiation of u of t minus a is delta times of t minus a. Got it, everyone?
Ma'am, will the graph change? Like now the plotting change because it's delta or something?
Yes, we are trying to plot that. We'll plot this. We'll plot this signal now. Okay. So how will delta t look? Unit impulse signal has an amplitude of 1 at t is equal to 0. Correct? Impulse signal, this is unit impulse signal. Okay, delta or unit impulse. Impulse signal will exist only at t is equal to 0 with an amplitude 1. Correct? This is
Yes,
our
ma'am.
delta t. How will delta t minus a look? What is it? It is shifting only, correct? It is shifting, just we are shifting this t minus a. So the signal is existing at 0 with an amplitude 1. So t minus a means where will the signal exist?
At A.
At A with an amplitude
1.
1. Got it, everyone? Followed? Followed or not?
Yes, ma'am.
Just shifted version of impulse is delta t minus A. Okay. So for your reference, I'll just explain you. This is delta t, correct? It will exist with an amplitude 1 at t is equal to 0. So what is delta t plus 1? Where will this signal exist?
At -1, ma'am.
At -1 with an amplitude 1, correct? So what about delta of t minus 1? Don't confuse it with the signal. This is delta of t minus 1. So in delta of t minus 1, where will the signal exist?
At +1.
At +1 with an amplitude 1.
Amplitude 1.
Correct? Yes or no? Following or not?
Yes, ma'am.
Are you guys following?
Yes, ma'am.
So from where will delta of t minus 3 be located?
At +3.
At +3, you'll have an amplitude of 1. Okay. Similarly, just a minute. Delta of t plus 6, where will it exist?
At -6, the
Minus
amplitude
6,
is 1.
Where?
At -6, ma'am.
At -6 with an amplitude 1. Correct? Similarly, they have given a there, t minus a. We don't know what is a. So delta of t minus a. This a might be anything. It might be 6, 4, 5 or anything. Okay. So it is existing at a with an amplitude 1. Got it, everyone? Clear? Is this concept clear?
Yes, ma'am.
Ma'am.
Others, is it clear? So we have an impulse signal delta of t. Shifting is same. Okay. So that is what is operations on signals. So we have to do shifting. So if k is negative, then it is right shifting and the signal is occurring 3 seconds late. Okay. If you have k positive, 1 you have here. So it is left shifting and the signal is occurring 1 second earlier. Okay. Similar to that, t plus 6, delta t plus 6 is the signal is occurring, it is k is positive, it is left shifting and the signal is occurring 6 seconds earlier. Okay. Suppose if you have delta t minus a, k is negative and it is right shifting and the signal is occurring a seconds late. Understood, everyone? So this is
Ma'am, how t plus 6, ma'am?
t plus 6. Delta of t will exist at 0, right? It will exist only at 0 with an amplitude 1. Correct?
Ma'am, can you repeat again?
Impulse signal, what's the definition of impulse signal? It is 1 at t is equal to 0. It is 0 otherwise. Correct? Or if t is
Yes,
not
ma'am.
equal to 0, it is 0. And all other places. Only at 0, the amplitude is 1. In other places, it will be 0. Other time instance, it will be 0 only. Correct? This is the definition of impulse. Yes or no?
Yes, ma'am.
So t minus 3 means k is negative. So right shifting by 3 seconds. Whatever is at 0 will go to 3. Got it? K is
Yes, ma'am.
negative, right shifting, and the signal is occurring 3 seconds late.
Okay, ma'am.
T plus 6 means k is positive.
So, yeah, so
left
it goes to the
shifting,
left.
left shifting, the signal is occurring 6 seconds earlier. Got it?
Ma'am, this you have taken t plus 6 as just an example, right?
Yeah, just example to show you just shifting operations with respect to
Okay,
impulse signal.
fine, fine.
Okay, so we are in the derivative for x of t.
Yes,
Everyone
ma'am.
come back here. So we have d by dt of x of t, which is nothing but delta t minus a. We have plotted delta t and delta t minus a. Now we have to plot it together. So how will it look? Have to plot delta t minus delta t minus a. So how will this signal look? Delta t minus delta t minus a means what happens at a? What is amplitude at a? This is delta t minus a, but you have delta t minus delta t minus a. How will this look? What will be the amplitude at a? It will be plus 1 or minus 1?
-1.
Minus 1, correct? So this will be minus 1. Understood why? So this is delta of t minus a. So what will be minus delta of t minus a? Amplitude will be minus 1 at a. Correct? Yes or no?
Yes, ma'am.
Yes, ma'am.
Try to imagine these signals. Okay? How they are shifting. How? So this is time shifting. So this is amplitude. Amplitude shifting. Okay? Or amplitude scale. You're scaling it by factor minus 1. So this is amplitude scaling. Okay? Got it, everyone? Is it clear? Derivative of x of t, that is d by dt of x of t. Is it clear, everyone? Delta t minus a.
Yes, ma'am.
So we have plotted the derivative of x of t. Now we have to plot the derivative of y of t. So what is our y of t? It is t into u of t minus u of t minus a. So how will you derive this? Differentiate this d by dt of y of t. You have two functions here. Use product rule. Okay, so using product rule, what will you get? How do you use a product rule? You'll keep one function constant. You'll differentiate the other one. Plus, you'll differentiate the other one and keep one function constant. So here I'll keep t constant and I'll differentiate this. That will be delta t minus delta t minus a plus I'll keep this function as it is and I'll differentiate t with respect to t. It will be 1. So what is d by dt of y of t? It is t into delta t minus delta t minus a plus u of t minus u of t minus c. So how will you plot this? Are you guys following?
Ma'am, can you repeat it, ma'am?
Yeah, you have y of t. What is our y of t in the given question? T into u of t minus u of t minus a, correct? So these are two functions, right? This is one function and this is one function. So I have d by dt of xy, x into y. So I'll keep x and I'll differentiate y plus I'll keep y constant and differentiate x. That is what I am doing. I have t as one function and u of t minus a as one function. So here I have kept t constant and I have differentiated this. Differentiation of unit step is impulse. U of t is delta t minus u of t minus a is delta t minus a. Okay, this is first part. Second part is I'll keep this constant u of t minus a and I'll differentiate t with respect to t. That would be 1. Got it?
Yes, ma'am. Ma'am, you are applying product rule, right?
Yes, product rule I'm applying. Got it? Product rule. Understood everyone?
Yes, ma'am.
So now we have to plot this. Till here clear everyone? Following?
Yes, ma'am.
Yes, ma'am.
So we'll try to plot this. First we'll plot u of t minus a, and we'll plot this. Then we'll add these two. Okay, because this is one function and this is one function. First we'll try plotting this u of t minus a. You people know that u of t is a unit step which is starts from 0 with an amplitude 1 and it will go up to infinity. Correct? And u of t minus a is nothing but it is a signal starting at a. Correct? It will start from a with an amplitude 1 and it will go up to infinity. So u of t minus a will exist from 0 to a. We have seen this, correct? With an amplitude 1. Got it? Till here clear? This is we have done previously. That is what I have showed you. U of t minus u of t minus a would be a signal from 0 to a with an amplitude 1. Correct?
Ma'am, before applying product rule, ma'am, can we take that t within the bracket? I mean, multiply it to both the terms.
No, you do like this better. Don't multiply it. Do like this only. T into this one. Okay? So now you have u of t minus a, and we also plotted delta t minus a. How did that look? Delta t minus a was like this. Delta t existed at t is equal to 0 and delta t minus a existed at t is equal to a with an amplitude of minus 1. Correct? Now multiply with t. T into delta t minus a. How will this look? At t is equal to 0, will your signal be there here? If you multiply this with t, 0 into 1, it will be 0 only. Okay? Following? And at a, it will be, the signal would be minus a. Got it everyone? Understood?
Yes, ma'am.
At t is equal to a, the amplitude would be minus 1. Just a minute. So at t is equal to a, the amplitude would be minus c. Got it everyone? At 0, at t is equal to 0, 0 into delta t is 0. At t is equal to a, the amplitude is minus a. Got it?
Yes, ma'am.
So now we have to add these two. This and this. This one and this one. So how will it look? That is your differentiation, right? It is t into delta t minus a plus u of t minus a. So how will your signal look if you add these two? Addition from 0 to a, you have this, and at a you have amplitude of minus a. So it will be from 0 to a with an amplitude 1, and at a you will have this impulse at minus a. Got it? This is your differentiation of y of t, that is d by dt of y of t. Understood everyone? This is your final signal. That is d by dt of y of t, which is equal to t into delta t minus a plus u of t minus a. We have added this u of t minus a plus t into delta t minus a. Got it?
Yes, ma'am.
Okay, we'll continue in next class. It's time up. Till here, it's clear, everyone?
Ma'am, can you show the screen, ma'am?
Ma'am, can you show it once more?
Yeah. This is u of t minus a. This is u of t minus u of t minus a. And this is delta t minus a. If I multiply that with t, at t is equal to 0, if I 0 into amplitude 1 would be 0 only. So, and at a you have amplitude as minus a. Okay, if you add these two, you will get this. That is your derivative of y of t. If we add these two, we have got this. We'll solve more problems, okay? So from 0 to a, the amplitude is a. Okay, at a, the amplitude is minus a. Clear, everyone? We'll solve more problems, okay? So this is just the beginning. So we'll solve more problems on this until you are perfect with this. Done, everyone?
Yes, ma'am.
Okay, clear?
Yes, ma'am.
Okay. You have any doubts still here? So if you don't have any doubts, then we can wind up this class. Thank you, students.
Thank you, ma'am.